Hello everyone and welcome to Java Basics. This is the moment we've been waiting for. We will create a simple web application that will let us play the Wordle game. Notice that we will take a lot of shortcuts and follow up in the next videos to refine it into a worthy application. Having said that, are you ready to play Wordle in the browser? As it was the last time around, the code is available here. It's in the description too. Don't forget to star and follow me on GitHub while you're there, and here too while you're at it. In this video, I'm going to make some intentional coding mistakes, things that you shouldn't do in a web app. My purpose is to show you how we can fix these correctly as we move forward. Without further ado, let's jump into the code. First, we need to add a new ThymeLeaf template, for which we will pick the name Wordle Guess. The HTML suffix is added implicitly by the IDE. Once there, we fix the title to Java Wordle, and we have our initial template. Now, let's add a bit of HTML, and for now, let's ignore the fact that it's a ThymeLeaf page. The p tag in HTML represents a paragraph. I'm adding a blank one here. Later on, if we have error messages, we can show them here. Notice the class statement. This isn't like a Java class. This is a CSS class, which we will get to shortly. In essence, this provides the browser with some hints on how you want the paragraph to appear. Next, we open the UL tag, which stands for unordered list. The default for that is bullets, but this type of list can be displayed in many ways. That's a subject for an in-depth HTML discussion, which we won't have right now. An unordered list is comprised of list items represented as LI entries. Notice that I add letters just so something will show on the screen and give each one of them a class. This will let us see how the final result will look before we write the actual code that implements this. Finally, I want to add the form that we will submit. HTML forms let us add and submit information to the backend. They can include buttons, text, input, etc. In this case, we have the input field named guess. Notice that the form tag accepts two attributes. The first one is the action. The action indicates the URL to which we will submit the form. Hash means the form will submit to the URL from which it came. That means that if we came from the URL guessMVC, the form will submit its input to that URL. The second argument is post. Post is a different HTTP method to get. You might recall our discussion about get and how it works. Post is very similar yet very different. As a refresher, get is the default. We get when we open the page by sending a request like this to the URL and then receiving a response. That typically includes an HTML page. Simple stuff. On the other hand, post only happens programmatically, or if we submit a form. That means we typically need to write some code to send a post. A post includes a body, which in our case is the information we placed in the form. In this case, it's the value of the field. To be fair, we can pass values in a GET request too, but traditionally post is considered to be a better choice for that, as it doesn't show all the values in the URL. After receiving the data in the server, the browser can receive the HTML back like a typical GET request. We can see that we have two input entries in the form. One is a text field and another is a submit button, which will submit the content of the text field. Let's start by creating a new package for the web UI and name it web. We can then add a new web controller class, which will work as the Spring MVC controller for the Thymeleaf template we just created. First, we need to add the stereotype controller as we discussed the last time around. When we add the required args constructor annotation, this will let Spring inject the field for the Wordle service as we discussed the last time around when talking about IOC and Spring. This is a hack for now. We'll just keep the list of the word guesses. This is a bug. I'll explain why in the next video, but for now we need some way to remember the guesses, so this is simple. This is the most basic hello world get. Notice we return the template, but do nothing since there is nothing to do here. Next, we need to run this. There isn't much to see here. At the top, we can see the list and notice that the formatting looks the same for all the colors. I also had a typo where I wrote the letter B twice. Then there's the guess text field and the submit button. If we will press the submit button, we will get an error that the post method isn't supported. But first, let's make the UI look a bit more decent. We'll start by defining CSS. CSS stands for Cascading Style Sheets. Typically, they are defined in their own file, but for simplicity, I'm including them under the style tag here. Notice that the syntax matches the names of the class attributes we saw earlier in the HTML without the corresponding dot. This is called a CSS selector, and it lets the browser know how to bind the definitions we provide here to a specific HTML element. We start by setting the colors for each one of the entries to its respective background color. Then the foreground color where applicable. An error is simply a red text, so color red is enough for that entry. Since black won't look good on green or on black, we make the foreground for both of these white. Padding means we want to add a bit of spacing around the component. We use millimeters as a unit so it will work consistently in very high density displays. That's a subject for a big discussion. Once we made these changes and also update the second B letter, we can see the colors look much better. We can now start adding Thymeleaf support to the file. First, we need to add the Thymeleaf HTML namespace, otherwise we'll see a lot of warnings in the IDE. I can now replace the blank error message with an error message from the controller. Notice I have a typo that happened a few times in the file because of the Wayward IDE plugin. The last closing bracket here is in the wrong place and should be within the quotes. This happens a few times in the code later on too. This is fixed in the GitHub source code. Let's move into the controller code and see how we can map the error message and the post. Since this is a post method, we create a new post mapping entry to grab the HTTP post. This works very similarly to the get mapping. Notice I pass an argument for the guess text field, and Spring is smart enough to understand that if a request includes a field named guess, it will pass it as an argument to the method. There is a lot going on under the hood here to enable that behavior. The first line is identical to what we do for the REST request. We validate the input. We then check if there is an error. So far, we're almost exactly like the REST request, but this is where things start to change. If there's an error, we add it to the model so it will be printed. If there's no error, we still set it to a blank value so the template won't fail. I could technically check if the value is set within the template, but I usually think this is simpler. Templates are harder to debug, and when they have an error, it's harder to read. I prefer them as simple as possible. Going back into the browser, we can see that the error works as expected, but the guesses themselves still don't appear here. We need to model the entries so we'll get Wordle style results. We need to return a new type that will represent what we need here. Let's create a new record type called web result. In a web result, we have a color and a letter. This will map directly to the two values we have in the HTML list item that we wrote before. This maps to the color attribute, so we will get the value from that record here. This will take the value of the character once we map this all together. Back in the record code, we will create a helper static method that will build an entry of web results for us. A web result is a single character with the color representing its Wordle status, but we need an array of those to match the characters in the string we received. This method accepts an array of colors and the string that generated it. It then converts that into an array of characters and colors together. We create the response array, loop over all the elements in the array, and create a new web result for each entry. The string class has a char_at method that returns a character at the given offset. Once we loop over everything and fill the array, we return it. Why do we need this? Let's go back to the web controller and see. We want to create a list of all the attempts words and their status. We have a list of all the attempts to which we always add the last guess. But these are strings. We want the colors as well. We can use a stream to convert the list of strings to a list of web response arrays. The map function is invoked for every entry in the list. str will have every attempt we made. We can now invoke the create method we just added and pass two arguments to it. One is the array of colors, which we already implemented in the Wordle service last time around. The second is the string we're currently iterating. Collect converts the stream back to a list, in this case, and assigns it to the result list. Notice that this is a list of arrays, which might seem weird at first, but it is perfectly valid. The last line we need is to add the entries to the model. Now that they are there, we need to implement this in Thymeleaf so our guesses will appear correctly. We added entries to the model, so now we need to access them here. But they are a list. How do we do that? That's where the each attribute from Thymeleaf comes in. It is a for each loop and will create additional li tags for every entry in the elements list. So with just this line, we will have as many list entries as there are attempts at guessing. We don't need the attributes here since we will push them through Thymeleaf. For every entry in the list, we will loop over all the elements in the array using another th entry. That is like a for loop within a for loop. We then access the properties for the color and character in the individual record to set the text and the class. This is a bit hard to grasp, so let's repeat that. This creates an li element for every entry. That means every attempt. This creates a b element for every character in each entry. Within those B entries, we set the class using this attribute. This replaces the A value we see on the right. It overrides the text for every B entry. With that, we can start guessing, and a basic Wordle with error handling and results are all working as expected. This is pretty great, but also very basic. There is one major bug here which we will discuss next time around. We also want to make this look like a decent web application and save its state. We'll go through all of those in the coming videos. In the next video, we will explain state in Web UI and we will discuss the possible fixes to the bug. If you have any questions, please use the comment section. Thank you.